So, Lamai, you're joining me the missile paper number 6 in CQ discussion. Let's go for the first one. Number of stable, this word is important, the number of stable resonance structures that can be drawn for oxalate ion. So, oxalate looks something like this with a negative charge here and double bond here. And a negative charge here. This is the oxalate ion. Now, as you can see here, the double bonds can arrange in different patterns. For example, this is the first pattern. Now, if I use the highlighter to show the bonds, double bond orientation here and here. That's the first way. The other way you can form double bonds is like this. That's the second way. Then another way which you can form is like this. That's the third way. Then another way what you can form is like this. That's the fourth way. So these are the only possible stable resonance structures possible for oxalate. So here the answer is 4. We can draw 4 of them, right? So third one is the answer. Third one is the answer. Then second one, which of the following statements is incorrect regarding benzene? The resonance hybrid of benzene is depicted as follows. No, resonance hybrid of the benzene is like this actually. This is not the resonance hybrid, it's actually the two resonance structures of benzene. So that statement is actually wrong. Second one, all 6 carbon atoms of benzene are sp2 hybridized. That's correct. Then third one, all bond lengths between any two carbon atoms of benzene have the same value. The bond lengths between any two carbon atoms of benzene have the same value. Yes, that's correct. They are undergoing resonance hybrid, right? They are undergoing resonance structures, and then what happens? The bond order will become how much? 1.5, right? The bond order is 1.5. So all the bonds of benzene will be equal in length. Carbon bonds are equal in length. All carbon, and carbon hydrogen bond angles have the same value. That's correct. It's 120 actually. 120 degrees bond angle and it's equal. All the hydrogen atoms of benzene lie on the same plane. That's also correct. They are on the same plane, like a sticker, right? So the answer is answer number 1. Then third one, this is a limiting reagent question. Let me take it to the screen. TiCl4 reacts with liquid magnesium metal to give titanium solid and magnesium chloride. So TiCl4 gas reacts with magnesium liquid in order to form titanium solid plus MgCl2 liquid, right? So 2 MgCl2 and then 2 magnesium. So this is a balanced chemical equation for the reaction. Then 0.95 kilograms of titanium chloride, that means 950 grams of titanium chloride, is made to react with 97.2 grams of magnesium. The reactant that is completely consumed, known as the limiting reagent. So how are we going to calculate the limiting reagent? First of all, you need to calculate the number of moles of titanium chloride and number of moles of magnesium each. So number of moles of titanium chloride, 950 divided by 190, which would be, I think it's going to be around 4, right? Oh, no. How much is it? 5, ne? 19 into 5, right? So that's 5 moles. Same number of moles of magnesium, we can take 97.2 grams divided by 24.3 grams per mole, which is around 4. We can take around 4, right? Yes. I think that's the correct answer. Let me recheck it. Yes, that's 4. So how I calculate in the limiting reagent or find in the limiting reagent, you have to divide this number of moles by the stoichiometry. So 5 divided by 1, that is 5. 4 divided by 2 is 2. So the lesser value. So the lesser value is 2, right? 2 is the lesser value. So that means magnesium is the limiting reagent. So if magnesium is the limiting reagent, magnesium will fully react. What they're asking is the amount of titanium solid metal formed. So number of moles of titanium would be half into number of moles of magnesium reacted. The number of moles of magnesium reacted would be 4 moles. So that would be 2 moles. So the mass of titanium would be 48 multiplied by 2, that is 96 grams. So magnesium and 96, that's the answer, is answer number 2. Right, that's the answer number 2. You can stop the video and write these things. I'm not going to wait. Right. Then the fourth one. The correct answer when the chemical species SO2, SO3, SO3 2 minus, SO4 2 minus, and SCl2 arranged in the increasing order of electron negativity of sulfur atom. So this is something which we learn under periodic variations. So SO2, SO3, SO3 2 minus, SO4 2 minus, and SCl2. If we draw the Lewis structures of each, it would be easier. So SO3, SO3 2 minus has a lone pair in the middle, okay? Don't forget that. Then SO4 2 minus, like this, and SCl2. SCl2 has 2 lone pairs. Yes, that's the structure. First of all, we are going to check with the hybridization here because all of them are sulfur atoms, right? When they are when they are the same atom, what we consider is the hybridization. So hybridization of SO2, 1, 2, 3, sp2. This one is also sp2. This one is sp3. This one is sp3. And this one is also sp3. So once you check with the hybridization, what's the next thing? You check with the charge. The charge of everything is 0 actually. So there's no positive charges here. What we check next is the oxidation number. Oxidation number of SO2 is +4. Right? The sulfur atom in SO2 is +4. This is +6. This is +4 again. This is +6. This is +2. Right? Chlorine is more electronegative. Phone calls variation. So chlorine is more electronegative than sulfur. So sulfur gets a +2 charge there. So according to this, we can tell the largest electronegativity are sp2. Among sp2, sp2s, SO2 and SO3, who has a large electronegativity? Then we are checking for the oxidation number, right? So SO3 has the largest. SO3 has the largest, then comes SO2, then comes SO4 2 minus, right? Because it has a +6 oxidation state. So the correct answer is answer number 4. Correct answer is answer number 4. That's the fourth question. Then the fifth one, identify the correct statement from the following. The bond angle of NF3 is larger than NH3. That's wrong. Ammonia molecule, the electron density near the nitrogen is very large. Electrons are pulled towards the nitrogen. On the other hand, NF3, it's different, right? Electrons are more towards the fluorine. So when the electrons are near the nitrogen, the bond angle increases. It's something we learn in the class. So that's wrong. Second one, elements in group 17 exhibit oxidation states from -1 to +7. Not all elements. Fluorine only has 0 and -1. So I'm going to just leave it here. I'm going to read the other questions and confirm it. That's how you mark MCQs, huh? Right? That's how you do MCQs. Monoclinic sulfur is the most stable allotrope of the sulfur in the room temperature. That's wrong. Not monoclinic sulfur. Rhombic sulfur is the most stable. So we do this on the energetics. So energetics, we tell you the most stable form of sulfur, which is rhombic. The density of graphite is larger than density of diamond. That's wrong. Diamond has a larger density, right? Diamond has a larger density. Aluminium chloride satisfies the octet rule in the gaseous state. Yes, aluminium chloride will dimerize in order to form Al2Cl6 in the gaseous state, which will give you a stable state compound, Al2Cl6, right? So the correct answer is answer number 5. So here, generally, this is correct. Elements in group 17 exhibit oxidation states from -1 to +7. That's generally correct. But fluorine, you can't take it. Fluorine only -1 and 0. So fluorine never shows +1 oxidation state. Never ever, because there is no element more electronegative than fluorine. Sixth one, the enthalpy change of vaporization, enthalpy change of vaporization of the liquid. What are? Enthalpy change of vaporization and entropy change of vaporization. Okay, let's look into that question. Alright. So in this case, the sixth one, Enthalpy change of vaporization is this much. Entropy is also given. They're asking what is the boiling point. So some of you might be messed up with this question and how to answer this question. So actually you have to refer to the place where the liquid boils. Right? You have to look into the place where the liquid boils. You know latent heat of vaporization, right? That's the place where the liquid turns to gas. At the situation where the liquid turns to gas. In chemistry, we tell at this state the reaction is reversible. H2O liquid convert into H2O gas at this place. The reaction is reversible. And at this point, we can tell delta G is also zero. Delta G gives to energy change is zero because this is the boiling temperature. Right? Delta G is zero because it's reversible. Now you can apply that equation delta G is equal to delta H minus T delta S. Right? So delta H is going to be the enthalpy change, and that's 45 kilojoules per mole minus T delta S. T we don't know, we have to calculate. Delta S is 90. 90 joule per Kelvin per mole. Then you can take it to the other side. Delta G is actually 0. So T into 90 is equal to 45 into 10 to the power 3. I'll put 10 to the power 3 because kilo. Now this one doesn't have kilo value, so I'm going to put 10 to the power 3 there. So T is equal to 45 divided by 90 multiplied by 10 to the power 3. That's 0.5. 500 Kelvin. They have given the answers in degrees Celsius, so you have to subtract 273 from this. That would be 7, 2, and 2. 227 degrees Celsius. Answer is answer number 5. 227 degrees Celsius. Answer is answer number 5. Look at the seventh one. H2S gas reacts with O2 gas to give only water vapor and SO2 as the products. H2S reacts with oxygen to give H2O plus SO2 gas as the products when 4 cubic decimeter of H2S. So first of all, let's balance this reaction. Is the reaction balanced? No, right? Hydrogen 2, sulfur is 1. Oxygen, it would be 3 here, then 2 and 2 and 2. Now it's balanced. Okay, 4 cubic decimeter of H2S reacts with 10 cubic decimeters of oxygen at constant pressure, the final volume of the mixture. Hurry. So here we have to consider using the volume, right? The volume is proportional to number of moles. Taking that the pressure and temperature is a constant using Avogadro's law only, we are taking this. Volume is proportional to the temperature. Sorry, volume is proportional to the number of moles. So by using that, we can tell, who's the limiting relation now? 4 divided by 2, 10 divided by 3. 10 divided by 3 is actually like 3 or something, right? So 4 divided by 2 is 2. So H2S is the limiting relation. So that means everything will react minus 4. Then this would be 3 over 2 minus 3 over 2 into 4. And this would be plus 4. And this would be again plus 4. So 2 into 2, 3 into 2, 6. 10 minus 6 is 4 cubic decimeters. This one also 4 cubic decimeters. This one also 4 cubic decimeters. So when you take the total volume of the mixture, you're going to get the answer as 4 and 4, 8 and 4, 16. Sorry, 12. 12 is the answer. So 12 cubic decimeters is your answer. So this is a new question pattern. If you don't know this, note this down. You can do this with, if they have given constant temperature and pressure, look, constant pressure and 250 degrees Celsius. If the pressure is changing, you can't do this because PV equals nRT. If pressure is constant, temperature is constant, R is anyways a constant. So volume is proportional to number of moles, right? So you can consider it like that and find the answer. Then eighth one, which of the following reaction steps is not present in the Born-Haber cycle of sodium chloride solid formation? So third one is the bond dissociation of chlorine, that is there. Actually, you have to break the Cl. Sodium solid to gas, that is there. That is, you can take it as sublimation as well as atomization. Both are correct. Fifth one is the lattice formation enthalpy, that is there. So first one is the dissolution enthalpy. No, that is not even dissolution. That sodium chloride aqueous just breaking up into sodium plus aqueous and Cl minus aqueous. If this is sodium chloride solid, then it's dissolution, but it's not dissolution here, right? This is something else, just breaking up into ions. This doesn't have enthalpy change actually, right? Delta H is going to be 0 for this reaction. There is no enthalpy change occurring. So this one is not there. Fourth one is there is the electron gain. Answer is answer number one. Eighth one, answer number one. Okay, then ninth one. Which of the following statements is or correct regarding to covalent molecules containing oxygen and sulfur? Or H2O shows amphoteric properties. That's correct. It reacts with acids and bases. The boiling point of H2O2 is larger than H2O. Yes, that's correct. And the reason is it can form more hydrogen bonds than water. Then CH2O2 can act as an oxidizing agent only in acidic medium. That's wrong. It does not act as an oxidizing agent only in acidic medium, but also in basic medium also it can act, right? It can act as oxidizing agent. The best example is H2O2 reacting with the MnO2 minus. In the basic medium, it forms MnO2, right? So those reactions we are going to learn under inorganics. Actual revision students, we have learned this. Rapid revision, you're going to learn it again. Then D, both H2S and SO2 have capacity to act only as reducing agent. No, actually, they can act as oxidizing agent also. So that's wrong. So correct answers are A and B. That's answer number one. Then 10th one, if an endothermic reaction occurs spontaneously at constant temperature and pressure. Okay, endothermic reaction, that means delta H is positive, occurs spontaneously at constant temperature and pressure. Enthalpy of the system decreases. So enthalpy of the system should increase, right? Because it's an endothermic reaction and it absorbs heat. So enthalpy of the system should increase. So actually C is correct and A is wrong. Then B statement, entropy of the system increases. So let's see regarding now, if it happens spontaneously, then delta G definitely should be negative, right? So delta H should be positive value. Then minus T delta S. So if delta S is positive only, this reaction will happen. Otherwise, this won't happen. Because minus into minus, minus into plus is minus. So minus and plus. So at higher temperatures, for it to be spontaneous, it should have a positive delta S. So entropy of the system should increase. Entropy of the system should definitely increase. Entropy of the system does not change. That's wrong. Because delta H is positive, right? Should change. So answer is answer number 2. Right? Answer is answer number 2. Then the 11th one, among the halogens, I2 is a solid whereas Br2 is a liquid. Yes, of course. London forces become stronger with increasing molecular surface area. That's correct. Here actually it's not about the molecular surface area. Here it's about the molar mass because I2 has a larger molar mass than Br2. I'll go for answer number 2 here. Right? I'll go for answer number 2 here. It's actually confusing. Like, which one should we take? Here, consider as answer number 1. Here, consider as answer number 1. The main reason why I2 has a larger, what do you call it? It's a solid. Actually, it's because of the larger molar mass. That's what you have to consider first. But here, they have considered stronger with increasing molecular surface area. They have taken it as answer number 1 in the past paper marking scheme. So here, go for the answer number 1. But if I wrote this paper, I would have put answer number 2 and I would argue for that. Right? These statement questions are very tricky. Like even the top rankers and like some teachers argue different ways. So yeah, it's going to be tough in some situations. So this is some question like that. So of course, I2 has a larger surface area, but the major factor what you're going to consider is the molar mass. I2 has a larger molar mass, so very large molar mass compared to Br2. For example, like Br2 is around 160. So iodine is around 220, 250 or something, 252 or something, right? So it's too much heavy. So molar mass is what you should consider there. But here they have taken it as answer number 1. So we'll go for answer number 1 there. Any two gases have the same average kinetic energies at same temperature. Any two ideal gases have the same average kinetic energies at same temperature. That's correct. At a given temperature, average speeds of molecules adjust according to their masses, and that explains the first statement, right? The speeds of the gas molecules will adjust according to their masses, right? So that's the answer. Answer is answer number 1, right? So with that, the missile paper number 6 will be completed. So this is the discussion for it. Get ready for the missile paper number 7. Make sure you do it. Make sure you mark yourself, right? And watch the discussion. And then until then, bye bye.